Right, I'm just mixing up the mortar here, sand and cement. 3 parts sand, 1 part cement, which is what we're going to bed the steel plate into the brick wall and onto the wall plate as well at the other end. We've done our measurements and we're going to be pocketing out the holes for that soon. Steel should be arriving later today. So yeah, just mixing this up. We're going to get it up on site and we can fix everything in place. So we're just figuring out exactly where the steel beam is going to go in here. We know that the dwarf wall, obviously the steel is going to be in here somewhere. The dwarf wall here is going to be about 800 high from top to bottom. But obviously these are going to be changed to 2x6s to allow for the insulation, and there'll be plasterboard and other bits and bobs as well. So we've measured down 850 from there. Obviously we can't go any further over here because of the chimney breast, you can't touch that. The steel plate that we're sitting this on is 800 wide, which is really, really wide. Normally we'd do them on 400 wide, but the structural engineer has specified 800 wide. So we're going to pocket out from here, 800 across, which is about there. So that section there will come out. And then we're going to have to sit the steel on this side of it, because we need 1.3 meters from here to here to allow 800 of depth from here to here. So that's where that's one sitting. What we did is we took out a couple of tiles and we went to the wall plate, the inside wall plate, and we measured back from there, and we figured out exactly that this is where the steel is going to sit. And then on the other side down here we've done the same. So measuring from this wall plate here back in 1.3 meters. Now that we've measured that, we know that the steel is going to end here. So yeah, we're now just bricking up. You saw me making the mix. We're sitting it on engineering brick. So 3 parts sand, 1 part cement, and then the water. We need to sit the steel a minimum of 30 mil above this wall plate here. Anything above that's fine, but it has to be a minimum of 30 mil from here to here. So that's why we build up this wall of brick. Going to get it nice and level and flat, and that will line up with the steel over there. Right, I'm just pocketing this out, as you can see. Nice and neat on the edges there where we've cut the bricks. Just going to level this one up a little bit more, down in line here, come down on these sides, and then work my way along just up to this one here. We've laid 1, 2, 3, we've checked them across. We've used the nice square flat timber to check the levels across, and they're all level. Being level across from here to here is not actually as important as it is from being level from there to there. So we've checked that a lot more closely and we're pretty bang on, so we're happy with that. And also we've made sure that we're square from front to the inside here as well, so that's good. So we just need to wait for the steels to arrive. They'll be here shortly and we can get them in. We're just marking up and measuring up now for where this ridge beam is going to go in, because there's going to be a square steel post which runs down here, and so we're going to be marking up and measuring up for that. Right, Chris has pocketed this one out, and if you see, if I line that straight up, you'll see it's not directly under the ridge. That's deliberate, because when we have the steel, the ridge steel up here, we need that to sit around here so that the joists can come above, the ridge can sit there, and then the dormer roof will come out this way. If we had the ridge up here, or the steel sitting here, the ceiling would be too high and would be oversized. So we've measured it It measures from that front wall plate there, it measures 3853 to the middle of the steel, which is bang on, as per the structural engineer's drawings and the architect's drawings. So we can now sit our steel on here, and it will be set on that engineering brick wall there. So we're in good shape. So we're just waiting for the steels to arrive now. Those are our steels. So we're going to get them to move these things up onto here, and then we can shift the timbers, get the steels up, and then the skip can go there. That is a big old steel, mate. How the hell are we going to move that? Are you feeling strong? Steels are getting put roughly in place straight off the lorry. We've got a couple here that we obviously can't put in, but these ones, scaffold is helping us. We're literally just running them straight in off the lorry. Right, I didn't catch most of that on film because it was all a bit frantic, but these are the spliced beams that are going to attach onto there, and that little one over there in the background. Got another long one here, got one at the back there. We've got a lot of steel to go in. We had the scaffolder here to help us. He said we haven't overloaded the scaffold just yet, but he said it's really tight, really close because of the weight of the tiles as well. So we're going to get all of these in now this afternoon. It's 2 o'clock, so we've got plenty of time to get these in, bolted up, sit the plates on back there in the pocket holes. Yeah, it's been suddenly busy, very, very busy, but we're there. To figure out where this beam needs to sit, how far forward or back this beam needs to sit. Obviously you have the drawings and everything, which is important, but also you need to factor in a whole load of other stuff. So we've got the thickness of this beam from top to bottom, which we know is 203mm, and then we've got the ridge beam, which is 160mm. So we've got those two, so you add those two together. Now we also need to include the fact that we've got 120mm of kingspan, we've got 50mm of fairings, and we've got ply lining and rubber roof to go on and all of that. So you cannot go over 2.66 as per the drawings. The drawings of the external height is 2.66. So what we need to do is figure out what all of our materials add up to, take that off 2.66, and that tells us what we're left with in terms of height to go from here up to here. Right, so we have now checked all of these for square. They're square to each other, they're square to the front of the building. We did it by measuring to the wall, top of the wall plate at each end, plumbing it, and then measuring across, and then we moved them as we needed to, this way or that way. Obviously we were very conscious that this one almost acts as a datum, because if it's too far this way, then the whole roof will be too big and we'll be way over our limits on the cubic, you can't go over 50 cubic meters. So we had to scooch this one as far as we could up against this brick, work off that so that we know our height, and then that acted as the datum for the others, and we've checked them all for square, and they are all square to one another and square to the building, which is really good. So now we can start cutting these timbers and running them in between.